is a warm-up on forces and free body diagrams. And we're going to look at a couple problems here, and then we'll move on to some other stuff. So first of all, we've got two children. This is number one. Two children pull in opposite directions on a toy. So it's, I'm going to make a free body diagram of this. Well, I'm not going to draw a toy. I'm going to draw a little square, which is going to represent the toy. One of the kids pulls with a force of 20 newtons to the right. So I want to do something really quick here. I want to show you the compass. Okay? And this compass looks like this. And this is right. And this is left. Right is positive. Left is negative. Okay? So one pulls with a force of 20 newtons to the right. And I'll write that there. You notice I showed the force acting on the body and on the toy, and the vector showing the direction to the right. This is to the right, and the magnitude of the force, 20 newtons. And the other pulls with a force of 5 newtons, and I'm going to change the color on this. I'm going to make this red, and I'm going to make it shorter. So the length of this bar is the magnitude, okay? And this one is pulling with a force of a magnitude of 5 newtons to the left. Okay, so you can see I've got this to the left. This is left, and this is right. Okay, just like the compass down below. Okay, so it says draw a free body diagram of the toy. Well, I've done that, and I've labeled everything. Then it says, what is the net force on the toy? Well, to get the net force, that means net means total. Okay, but the forces are acting in opposite directions. So one way, an easy way to look at this is to say, well, the net force on this object, F net, which isn't like Fn, it isn't F normal, right? This is F net, it equals, these are 180 degrees apart. One is to the right, one's to the left. Okay, they're completely opposite directions. One of them is positive, one of them is negative. So if I wanted to sum these up, net means total or sum. So if I want to sum these up, then it's going to be 20 newtons to the right, and the 5 newtons to the left is minus 5 newtons. Okay? And so the net force is going to be 15 newtons, and since it's positive, it's going to be to the right. Okay, it's going to be to the right. Now let's look at these two down below. These are kind of complicated, but they're not. They're just trying to make, trying to make a point, right? So first of all, there's the body, just like the one we just did. There's some kind of an object, and it has a force of 8 newtons to the right, and a force of 6 newtons to the left. And as we talked about, the right's positive, and left is negative. Okay? And so what is the net force? And let's talk about this real quick also. This is the x direction. Okay, that's horizontal. The y direction is vertical. Okay? So if looking at that, when it says, what is the net force in the x direction? Well, that means in the direction left to right. Okay? So the net force, well, it's going to be 8. That's positive because it's to the right. Minus, I'm summing these together. What is the net force, the sum of the forces, the total force? Minus 6. And the answer is going to be 2 newtons. And since it's positive, it's going to be 2 newtons to the right. That is the net force acting on this object. Okay? So let's talk about something real quick before we go any further. On the toy, there's a net force of 15 newtons to the right. And on number 2, on this one, 2A, there's a net force of 2 newtons to the right. So this has a net force acting on the body. So that means there is a net force. That means it's not in equilibrium. Okay? And that means that, just for future thinking about this, it's not in equilibrium, and it is accelerating, because net forces net forces cause bodies to accelerate. Okay, so it would be accelerating, okay, because it has a net force acting on it, because it is not in equilibrium. The forces are unbalanced. Okay, so let's look at this one. So when you have a number of forces acting on a body, like this one here, there's a whole bunch of them. Look at the ones that are acting in the x direction. So let's make a little compass here. This is the x direction, and this is the y direction. So you know which one's which. So now we can look. There are 3 forces acting in the x direction. Okay, and just remember that to the left is going to be negative, and to the right is going to be positive. Okay, and so you've got 3 forces acting in the x direction, and this one's going to be positive, and these 2 are going to be negative. So let's look at that. We've got 5, that's a positive net force, 5 newtons to the right, minus 2, so I'll just put a little check on this, minus 2, that's this guy, and minus 3, that's this guy. So the net force in the x direction is 0 newtons. Okay, in the y direction, okay, there's 2, okay, so this is up, okay, we'll say, and that's positive, and this is down, and we'll say this is negative, right? And so we have 2 forces acting in the up direction. Those are both going to be positive. So it's going to be 3 plus 1. Those are both the positive forces, minus a force acting downward, minus 4. So the net force in the y direction is also 0 newtons. So the overall F net for the overall object, okay, is 0. It's 0 in both the y and the x direction. The F net is 0. So that means it is in equilibrium. It is in equilibrium. And that means there is no net force acting on the body. That means it is not accelerating. It is not accelerating. So it could be 2 things. It could be at rest. It is not accelerating. It could be either at rest or it could be moving at a constant speed. But it's not accelerating because there is no net force on it. The forces on this thing are balanced. They're balanced. All the x and y forces are balanced. So it's not accelerating, it's balanced. It can be moving at a constant velocity, or it could be at rest, but it is not accelerating.